In question 33, we're asked to consider the set of 2 by 2 matrices, all of whose entries are non-zero real numbers. Which of the following properties is satisfied by S under multiplication? 1. S is closed, 2. S is commutative, or 3. S contains an identity. Let's start by talking a little bit about matrices and matrix multiplication. Well, first we're talking about 2 by 2 matrices, or multiplication with 2 by 2 matrices. Now, in order to multiply two matrices together, they must meet a certain criteria. And that is that their dimensions must adhere to the following principle. The matrix on the left, the row of the matrix on the left, is the first number, the number of rows. We always talk about the rows first and then the columns. So a 2 by 2 matrix has 2 rows and 2 columns. The column of the matrix on the left must be equivalent to the number of rows of the matrix on the right. So in order to multiply two matrices together, the number of columns of the matrix on the left must equal the number of rows of the matrix on the right. And in this case it does, being that they're both 2 by 2 matrices. When this happens, the resultant matrix from the multiplication will have the same number of rows as the number of rows of the matrix on the left, and will have the same number of columns as the number of columns in the matrix on the right. So a product of two 2 by 2 matrices will also be a 2 by 2 matrix. And so it is fair then to talk about the resulting set of matrices produced by multiplying two 2 by 2 matrices together, and the result of the multiplication of two 2 by 2 matrices will also produce another 2 by 2 matrix. So we can say that matrix multiplication of 2 by 2 matrices, of the set of 2 by 2 matrices, is closed under multiplication. So once again, the set of 2 by 2 matrices is closed under multiplication, and what that means is that when we multiply two 2 by 2 matrices together, we also get a 2 by 2 matrix. But that's not quite the question here. First of all, it says that these 2 by 2 matrices have entries that are all non-zero real numbers. So we may start off with two matrices that have non-zero real numbers, but we may end up with a resultant matrix that could have zeros in it. If we start multiplying two 2 by 2 matrices that have only all real numbers in them, then the result will also be a 2 by 2 that has only real numbers. But we can't guarantee the non-zero part of that. So for example, if I have the 2 by 2 matrix that is all 2's and another that is all 2's, but in the second row, first column, I have a -2. Well, because of the way that we perform matrix multiplication, we'll multiply first row, first column of the one on the left times first row, first column of the matrix on the right, and we'll get 4, but that element is not done yet. We're going to add to that the product of the first row, second column on the left and the second row, first column on the right. And so first row, first column in the resultant matrix would be 4 minus 4, or 0. So this is a simple example that we are not closed under multiplication when the entries are all non-zero real numbers. Second, in general, matrices are not matrix multiplication is not commutative. And third, if we want to talk about an identity is a matrix that is a square matrix that has ones in the main diagonal going down from left to right and has zeros in all other positions. By definition, since this has zeros in it and yet our set S, the matrices in set S have all non-zero real number entries, then this cannot be true either. And so the answer is A, none.